Alright, we're on a Unit 4 already. So, before we get into how to actually name chemical compounds and the like, we need to first understand a couple of the notations that you're going to see around in your chemical formulas, okay? Because they can get students really confused. So let's go ahead and label some of these things. First off, this is calcium, that's Ca. And just as a little bit of review, this positive 2 is what we call a superscript. And that is the small little number that's in the upper right hand corner. Now, we know that Ca positive 2 is what we've referred to as the charge. Okay, the charge is the same thing as an oxidation number. So if you see oxidation number, don't get confused. That just means the charge. There's a couple other ways that you'll see some formulas written that are going to have some other numbers, and it can get a little bit confusing on you, okay? So let's say we have CaCl2. Now, this number right down here, that is not the charge, okay? This is what we would call the subscript. Now the subscript, what that stands for is how many you have. So how many atoms you have. So if there is no number below, like on this one, that actually means that there's a 1 there, okay? So if you have CaCl2, that means we have 1 calcium and 2 chlorine. Now, another thing that can be different is if you get something like this. Okay? Now, this number right here is a coefficient. Okay, so let me show you how this is different. If we have 2CaCl2, okay? What that means is I've got a Ca and it's got 2 Cl's attached to it. Okay, that's how I got my 1 calcium and my 2 chlorine. But because I have this coefficient in the front, that means I actually have 2 of these. Okay? So now in reality, how many calcium atoms do I actually have? Well, because of that coefficient in front, I take this imaginary 1 right here and I multiply it by the 2, and that gives me 2 calcium. And how many chlorines do I have? Well, it's 2 times the 2 over here, which means that I actually have a total of 4 chlorine. And we can see these 4 chlorine here, 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 and here. So if we have a problem where it asks how many atoms are there in a compound, we have to make sure that we look both at the numbers below and if there's any numbers to the front of the formula. Now I'm going to show you a couple examples that can throw students for a loop, okay? Say I've got, let's do iron sulfate, okay? So let's actually do iron 3 sulfate. So I've got Fe2SO4 3. You see some of the issues that can come up here. What's this parentheses thing? Well, the parentheses essentially means this. If I were to draw this molecule, I've got an Fe and an SO4 and let me just let's not get into that. I've essentially got 2 Fe's, right? And in this molecule I've got 3 SO4s. So when you have a number outside the parentheses, of a polyatomic ion, that means you actually have 3 of everything inside, okay? Now, that's going to kind of work like it does in math, all right? So, for example, let's see if we can get how much of each of them we have. So we have Fe here, and we have S, and we have O. Now, for the Fe, we've got 2 of them. That's the number below right here. That's pretty easy. So we have 2 Fe's. What about, though, the S? Well, usually we would just have a 1 here underneath the S, because there's no number there. It'd be just like 1. However, just like in math, if you have a number outside the parentheses, it multiplies everything inside. So instead of having just 1s, we have 1 times 3, which gives us 3s. And then for oxygens, I have 4 times the 3, which gives me 12. Okay? And that makes sense. If we look at what we had here for our little formula, I've got 2 Fe's. I have 1, 2, 3 sulfurs. I have 4 oxygens, plus 4 gives us 8, plus another 4 gives us 12. Now, one of the last things that can be a little bit confusing, and I'll just show you that real quick, is if we have something that looks like this. So not only do I have numbers on the bottom, I also have parentheses, and I have a number in front. But let's go ahead and let's do this, okay? It's not quite as hard as it may seem at first. Now, this 3 means I've got 3 molecules, okay, of that whole CaOH2, okay? The 3 in front is the coefficient, and that again is the number of molecules. So here's what we're going to do. I have where we multiply, if there's a number on the bottom, by something in parentheses, but we also need to multiply it by the coefficient in front. So for example, here's calcium, and I have 1 normally, and it's not inside the parentheses, so we're not going to multiply it by 2, but I have 1 times the 3 in front, which gives me 3 calcium. Oxygen, there's no number there, so I have 1 of them. 1 times the 2 on the outside of the parentheses, which gives me 2. 2 times the number in front, which gives me 6. And then lastly, I have my hydrogen here. I have 1 because there's no number there, but it's in a parenthesis. So I have to multiply it by the number outside the parentheses, which is 2. So 1 times 2 times, again, the 3 in front, which gives me 6 total. And so that's how we use the numbers on the bottom, the subscripts, and the numbers in front, the coefficient, to find out how many molecules we have, that would be the coefficient, and then how many atoms. And to get the atoms, again, we have to take any number on bottom, multiply by a number that's outside the parentheses, and then also multiply by the coefficient that's in front.